All right, now we're going to be graphing with slope-intercept form. So for number 7, I've got the equation y equals 2x plus 1. It's already solved for y, so it's already in slope-intercept form. And my instructions are to graph using the slope and y-intercept. In this case, if my equation weren't already solved for y, I would want to make sure I solve for y first. So anytime you're asked to do something using the slope, the y-intercept, you can get that by solving your equation for y first. In this case, it's already in slope-intercept form, so I'm good to go. So y equals 2x plus 1. That plus 1 gives me my y-intercept. So this means that my y-intercept is the point 0, 1, so I can go ahead and plot that y-intercept. So that's step 1, plot the y-intercept. Step 2, I can see from the coefficient of x that my slope equals 2. Remember, your slope is not 2x. There's never a variable in your slope. It's just a constant. So my slope is 2, m equals 2. So for step 2, I want to use that rise over run definition of my slope to find the next point on my graph. So if I ask you guys on a test, what's the slope? You guys tell me 2, period, end of sentence. That's the only correct answer. As you're graphing, if you want to think of your slope in terms of rise over run, the slope of 2, I could think of it as a 2 over 1. Okay, so this is to graph my second point, and specifically it's a positive 2 over a positive 1. So from my 0, 1 ordered pair, if I rise up, positive 2 up there, and then run to the right, positive 1, that puts me at this point. Okay, so I only need 2 points to graph a line. I've plotted the intercept and I've plotted a second point, so I could certainly connect these together. But for a couple of reasons, I actually am going to find a third point just kind of as a check and just to make my line straighter. I'm kind of terrible at drawing straight lines, so it's better for me to draw a straight line through 3 points rather than 2. It gives me a little more guidance. Okay, but at this point, we have enough to graph the line. We could go ahead and connect these two and graph our line. But I also want to show you guys an alternative. We have m equals positive 2. I could also write this as negative 2 over negative 1. Negative over negative simplifies to a positive, right? So in this definition, negative 2 means rise down 2. Negative 1 means run to the left 1. So again, from this y-intercept, if I go now down 2, and then I go to the left 1, that puts me at this point. Okay. So you can see that both of those points land on the same straight line, the same positively sloped line. I just want to mention that for rise over run, you can either do positive over positive for a positive slope or negative over negative for a positive slope. That could come in handy, for example, if you had a y-intercept of like 0, 6, for example, and you run out of axis. You can't plot, up 2 and over 1 because there's nothing there, but you can go down 2 and to the left 1 in that example. So just remember that you have both of those options that could come in handy. Okay, for number 8, we want to graph y equals negative 1/5 x plus 3 using slope and y-intercept. From the plus 3, I can see that my y-intercept is the ordered pair 0, 3, so I plot that on my y-axis. My slope is negative 1/5. Now for rise over run purposes, I could think of my slope as either negative 1 over positive 5, which means from my y-intercept, I could go down 1, rise negative 1, which means go down 1, and then run to the right 1, 2, 3, 4, 5. So that puts me right there. Or I could think of this as a positive 1 over negative 5, just for rise over run purposes, not for my final answer of what's the slope. That's going to be negative 1/5. I don't want that negative sign in the denominator. But just for rise over run, I could also start with my y-intercept. My positive 1 rise means goes up 1. My negative 5 run means go 1, 2, 3, 4, 5 to the left. okay? And then I can connect these. So connect this straight line. And this gives me my graph using slope-intercept form. All right, let's look at number 9. Graph y equals negative 3x minus 2. So I have a y-intercept of 0, negative 2. And then I have a slope of negative 3. So my slope is negative 3. If I want to think of this in terms of rise over run for graphing, this is equal to negative 3 over positive 1. So I can go down 1, 2, 3, and to the right 1. Or I could also think of this as positive 3 over negative 1. So from my y-intercept, I could go up 1, 2, 3, and then to the left 1. And then I draw my straight line. Now, again, notice that I have 1 negative, 1 positive, or 1 positive and 1 negative. I only have 1 negative in one spot. Sometimes students just fall into the trap of thinking that this would be equal to negative 3 over negative 1, but of course that's actually equal to positive 3, so just keep an eye on that. And as a check, if you have a negative slope, make sure that your line looks like it has a negative slope. I have a decreasing function, a decreasing line, so visually I do see that negative slope. Same thing in number 8. I see a flatter slope, but I see a negative slope as well. In number 7, I see that increasing pattern, so I do see that positive slope after I graphed it.